So what's the one single biggest thing that's stopping you from creating your own APIs for your projects? Well, generally for most people, it's going to be something to do with the database, like setting up the environment, managing the connection, or dealing with the different interactions to get and put your data. So in this tutorial, I'm going to show you a really simple way that you can manage this interaction with the database using the Type ORM. So we're going to see how Type ORM can be used to actually set up the database connection and handle all of the interactions for us. And because it's a TypeScript based library as well, we can use the types that we create for Type ORM in our front end app as well. So we're going to be creating a sort of to-do list app, and it's nothing too special, but let's have a little demo of what we're going to be creating. So we've got this web interface that's been created in Angular, and essentially we've got an input where we can put in some text for it to do, put in a date for it to be completed, which isn't relevant actually to the app itself, and then click the create button, and then we get entries in the to-do list table, which we can then update by clicking on the complete button, or we can remove them just by clicking on the trash icon. So nothing too groundbreaking here, but we're actually storing all of this data in a database using the Type ORM system. And you might notice if I actually do some interactions in the to-do list table that we're getting SQL generated for us by Type ORM, and that's actually managing the database for us and managing the data that's stored in it. So that is an overview of the project. Let's have a look at how we can get this set up and get you working with Type ORM really quickly. So the first thing I'm going to do is just reset my environment, and I'm just going to go over to this branch that we've got on this Git repository, and that's just removed pretty much everything that we had already set up and running in that to-do list demo. So we've got two components to our project. We've got the front-end app, which can be written in any language, by the way. I'm just using Angular as an example here. And we've got a server folder, which is where we're going to create all of the necessary stuff that will interact with our database. So I'm actually just going to remove that app folder and then recreate it using the Angular CLI. So in here, I'm just going to, let me open up a new terminal so you can see what I'm writing. So we're just going to use ng new and then app, and that will create a framework for the front-end app that we're going to be using. And we'll let that go and do that thing. So we're going to actually work on the server side first of all, and then we'll start incorporating some of the calls into the actual front-end app when they're ready. So we've got some node modules left over here, so we're just going to ignore those for the moment. But let's go back into the server directory that we've got set up, to clear down what we had there. And the first step really is to actually get all of the dependencies installed and set up. So I'm just going to create a new project in this directory to start off with. So we've got our package.json in here, and we're just going to fill in what we actually need for our project. So it's going to be a few things to start off with. We're going to need Type ORM, of course. So let's install that, Type ORM. We want to also include TS Node and Express. We're going to be running an Express app, and the TS Node and NodeMon packages here. And the TS Node and NodeMon packages will just allow us to compile and run the Express code as a TypeScript code, which is really handy because then we can start making use of interfaces, which Type ORM will be using as well. Let me just close down this other terminal here so you can see what I'm typing. Okay, so NodeMon, and the other thing that we need as well is a database to store our data into, and you can use different types of connections and connectors for Type ORM, but we're going to be using SQLite just to save a file with all of our data in our local folder for Type ORM here, and that'll just make the tutorial a little bit easier to follow along with. So we'll just install those, and that should just take a second, and it should then fill up our dependencies in our package.json file. So that's pretty much all we need for our API, but I'm also going to install the cores package as well, which will just allow us to run the Angular app on a different URL, a different port, but in production you probably wouldn't need to do that. The other thing is for our dev dependencies as well, just to help us out here, I'm going to install some types for cores, the package that we just installed, and also for Express too. So let me install those as dev dependencies. And now you can see we've got our package set up and ready to go. So just before we finish with our package.json file here, let's set up a script to actually run our server code. So we're going to say, just say serve, could be the script we want to run. And that's just going to use nodemon to run a file in our local directory here, and we'll call it app.ts. So that's the next thing that we're going to do. We're going to move on and have a look at this app.ts file, which will basically be the server file that we're going to run, which will serve all our data and connect to the database and do all of that handling for us. So let's create app.ts. And the first step that we're going to do is basically set up the Express app. So we're going to import Express from the Express package. And we can also import the request and the response objects as well from Express, and we also want to import cores as well, so we can run our API without having to worry about the cross-origin requests. And then we can create a new app, a new Express app, just by calling the Express function. And then what we want to do is a few bits of setup here. First of all, we want to make sure that JSON data can be accepted when we're putting or posting data to the Express app. So we use express.json, and then app.use the cores function that we just imported. So that's pretty much all we need to do to create the app. Let's set the server actually listening here. So we'll say app.listen, and it'll be port 3000. You can choose any port you like. And then when that is set up, we are just going to log a message out to the console to let us know that that's all set up and running. There we go, app listening on port 3000. So now if we run that npm script that we created a moment ago, we can say npm run serve, I think it was. And now you can see that nodemon is running, and we've got the app listening on that port. And if we were to just go to localhost 3000, we'll probably see an error, but we can see that there is a response from the Express app. So that's all set up and working nicely. So the next thing that we want to do before we make any more progress with creating endpoints in our API is to actually get connected to the database using type-orm. So in our server folder again, let's create a new file. And this is going to be for connecting to the database using type-orm. So to do that with type-orm, we import a data source class from type-orm, from the package we've installed, and then we create a new instance of that package so that we can actually make a connection to the database, but we need to tell it what type of database we're connecting to and then credentials that are required. So I'm going to export from here a new instance of the data source. And we need to pass in some configuration to it, as mentioned. So the first thing really is the type of database that we want to connect to. So I'm going to connect to SQLite. And the database, we just give the database name, and this is the file name that the SQLite will use to store all of the data that's being used. So we'll say todos.db, and there's a few other options that you can kind of add for synchronizing the database on loading. Any logging is useful as well, just to see what's happening in the console. And also we're going to have entities, and this is going to be where we're going to put our data models, and that's what we're going to do in the next step once we've connected to the database. So that's pretty much all you need to do, but this data source object doesn't do anything on its own. We're not referencing it at the moment. So what we need to do in our app.ts file is connect to the database and actually initialize the database connection. So we can do that just by importing the data source into this file, and we get this initialize function on the type-orm data source that we've created, which actually returns us a promise. So we can say there's a then and also a catch if something goes wrong, which will catch any errors, which is useful if we've got any problems with any of the endpoints that we've created. So when the database is initialized and everything's okay, we can then proceed to actually set up our Express app inside this initialize then block here. But of course, if there's any errors, we'll just log those to the console, and we won't initialize the Express app, so we can always tell when there's a problem. So let's just log that out here. So now when we save the file, you'll notice in the console that we're getting some of that logging appearing there, and that's happening before the app is actually connected. And all this is doing is just telling us these are the queries that TypeORM is sending to our database, and it's just a bit of setup in this instance because we haven't actually created much yet. But you'll also notice in the server folder there's now a todos.db file, and that is where all of the data gets stored to in the SQLite database. So that is pretty much our database connected. What we need to do now is actually tell TypeORM what type of data we're going to be storing in it. And because we've just got the one simple model that we're going to be using in our app, which is the to-dos, we can create a to-do model and then fill it out and show TypeORM what type of data we actually want to store in there. But one of the advantages of using a TypeScript-based ORM is that we can use some interfaces to make sure that the objects that we're creating conform to the type of data that we want to use and are expecting to see. So before we actually create that data model, let's create an interface here, a TypeScript interface. So we're going to say I-to-do, so interface for to-dos, and we're just going to export an interface of I-to-do. And then this is going to be the data that we'll see in the front end, but also what we're storing in the database as well. So we need a few bits of information. We're going to have an ID, which is just a number. We'll have a task, which will be the thing that the actual to-do is about, like the text for the to-do. The date due, which we can specify as a date type. And then also we'll have done, which is Boolean. And what we might want to do if you're kind of working with things that need to be ordered by date, for example, is have the date that they were created at and also when they were last updated as well. And we'll see in a bit how TypeORM can be utilized to actually fill these bits and pieces of information for us automatically, so it's useful to have those in the interface. So the next thing to do really is to actually create this data model, or as TypeORM likes to call it, the entity, which will make use of the interface that we've just created, and then we can plug that into TypeORM to control all of the different tables that need to be created. So again, in the server folder, we're going to create a new to-do file, a todo.ts, and we start this off by using the entity decorator, which is provided from TypeORM. And then we export a class that uses this entity decorator. So we'll say export class to do. And then we can also force it to implement the to do interface, the I-to-do that we just created a moment ago. And now this is the data model that we can specify the type of data that we want to use in our database. But there is just a problem at the moment. It's probably going to be related to this entity, and that is because we need to do a bit of TypeScript configuration for TypeORM to work correctly. So we don't have any tsconfig files in our server directory at the moment, so we can generate one of those just by saying npx tsc and then init. So that's the TypeScript compiler package, and we're just asking it to initialize this with a new tsconfig file. And once we've got that file in our directory, there's a couple of things that we need to enable, and that is experimental decorators and emit decorator metadata. So this is all in the instructions for TypeORM if you follow through on their website. But yeah, that's all you need to do to actually get that set up and running. So now we've got an entity class, we just need to fill in the different types of data that we want to store, and we're just going to basically copy what we've got here in the interface, which is why TypeScript's kind of complaining at the moment, because we haven't implemented all of those different properties that are on the interface. So the first thing we want is a primary key for our items in the database as well, so something to identify them uniquely. So we're going to use a primary generated column decorator, which TypeORM provides us, and then we're just going to give that the ID of number. So by default, TypeORM will just use like an auto incrementing integer number, so we go 1, 2, 3, 4, etc. But that should be enough for our purposes. So each to do will have a unique ID number, and then the rest of the columns for our model can just be decorated with the column decorator. So well, here we go, column, and the first one was task. string, and another one for date due was the next one. That's a date. And the other one was done, which was a Boolean. And then the other two, which were for created and updated, there are a couple of different decorators that we can use to auto-populate those for us. So create and update columns are the two decorators that we want to use, and just need to make sure that they are set as the same property names for our date. So created at date, and then update date column, updated at, and date. So if you're wondering what those are, basically they're automatically populated into the database every time we create a new to-do, and also when we update one as well, that will get a new timestamp on there. So you can use that in your app, although we won't be using it in our front-end app today. So let's fix some of these errors here. So the decorators need to have the parentheses, and what is going on with these? Okay, so each of the properties is looking like they need to have a value assigned. So this is just a TypeScript configuration. So there is an option we can turn off here. So strict property initialization. So this is just turning that. Let's turn it off. This is just turning off the requirement to have a value assigned to this model when it's created, because TypeORM will handle that for us. These are all required, they're not optional basically. So once we've created this to-do model, we want to let TypeORM know that we're going to use it as our part of our data source. So back in the data source file in entities, we basically just import the to-do model that we created and make sure it's set in the entities array there. And of course, if you're creating multiple entities, you would just add them all into here. But that should be now configured in our TypeORM system to recognize these to-do data models or entities. So now we're in a position where we can actually go back to our Express app and create some of the routes to make use of the database and TypeORM to actually get some data and put some data in. So let's go over to the app.ts file, and once we're inside of the listening function of our Express app, we can then start to work with the routes that we want to configure. So the first one is going to be the get route. So we're just going to get /to-dos, which is going to be the resource that we're going to be managing in this instance. And what we want to do, we're going to create the callback as an asynchronous callback, so we can use the await keyword, and we're going to have request, which, if you can remember, is the request interface that we imported above, and also response. Let's just have that as res response, and then this is what we want to do when we make a call to /to-dos in our server app. So we're going to basically use TypeORM to get all of the to-dos from the database, but in order to do that, the best thing is to use a repository with TypeORM to manage all of the connections to the database and any of the requests. So outside of this get route, what we're going to do is create a variable called to-do repository. And you can think of this as kind of like the connection being managed and being able to work with TypeORM. So we're going to get a repository on our app data source, and we pass in the class of the to-do entity that we created just a moment ago. So now in this to-do repository, we've got loads of different functions that we can use to actually interact with to-dos in our database. So let's go into the app.get route we've got here. And all we want to do when we actually call this route is retrieve all of the to-dos in the database. So let's create a new variable called all to-dos. And we're going to await the result of the to-do repository .find. And the find function basically finds everything related to this model in the database, so we'll get all of the to-dos that have been already stored. So once we've got that, we'll just return from our endpoint the bit of JSON here. So we'll say the status is okay, and the data is just the result of all to-dos. And if we do actually try that out in the browser now, so go to to-dos. Oops, the server isn't running anymore. Well, let's restart that again. Okay, you can see a bit more logging here now that we've got the data model in place. You can see it's created the table for to-dos and set up all the different fields in the database for us. So now you can see we're getting some data back, which is just the status of OK, because we don't actually have any to-dos created in the database. So that is the get route for our app, and that's the read part of the CRUD operations that we're going to be creating. So probably the next thing that's probably worth doing is looking at creating new to-dos, because then we get to a point where we can actually put stuff into the database and see the result coming back. So we're going to create a post route. So app.post, and we're just going to post to to-dos, and let me just copy this callback signature here because it's going to be exactly the same. And then what we're going to do in here is take a request object, get all the data that has been sent from the front end, and then just put that into the database. So let's have a look at how that post will look. So we're just going to, from the request body, get the data. So this is why we used Express.json before. And we can actually type this data as a to-do interface because it will have the same format as been passed in from the front end. And then all we need to do once we've got that data that's been passed in from the front end, we can say the result is equal to an await for to-do repository. And we can call the save function because we've got the complete object, and save data. And then once we've done that process of saving it into the database, we'll set the status to OK in our response. And then we can also pass that result variable back as well, just to see what kind of information gets stored. So if we save that, and we can't actually test this out in the browser just at the moment because we need to send a post request and we don't have an app to do that yet. So let's head on over to Postman to do that. So if we wanted to send get request here to to-dos, we should find that's working as it was before. Make that a bit bigger. But we want to post some data into it. So the body, we want to send some JSON, and we need to follow the same interface that we set up for our to-do model that we created. We don't need to worry about the ID because TypeORM will sort that out for us. Task, due date, and done need to be provided, and the create and update columns will be handled automatically as well. So what we're after is task, do the dishes, date due, which could be an ISO string or something, but let's just put in a standard date format here. And then the final property is a done, which is a Boolean. So we'll just say that's false for our example here. So let's just open this up a little bit. If we send that request now, so don't forget we've set up the post route, and you can see this is the data that kind of comes back. Let me open this up a bit more. You can see we've passed in task, date due, and done, but the ID and the created at, updated at columns have been created automatically for us. So what we should find now, if we send a GET request to the same endpoint, we'll call the other route that we just created. We've got one to do in the database, and that is the same result that we just saw a moment ago. So we've got that mechanism at the moment now to actually put something into the database and actually retrieve something as well. So it might be a good idea at this point to actually test this out in our front-end app, get that set up, and then we can implement the rest of the routes just to finish off. So let's go back to Visual Studio Code. So the first thing we're going to do is if we just navigate into the app folder here in our terminal, because what I want to do is create a component that will hold all of the to-do information in a table. So it's always a good idea to componentize things when you can, and this is just a good example of how we can create a component to hold that information and then deal with the inputs and outputs, which is also a really useful thing to learn in Angular too. So let's actually use Angular to generate a new component. So generate component, and we'll call it to-do table. So the only thing we're going to do with this table component for the moment is actually accept an array of to-dos and then just render them out in a table. So we can do that just by creating an input property on our to-do table component, and we're going to have it as to-dos. And we can actually use the interface that we created on the server side as long as we get the correct path for it to import. So let me just grab that from here. So we probably have some kind of shared folder if we were doing this as a larger application. But essentially we're going to just use that interface to specify what sort of data should be going into this table. And of course, there will be an array of to-dos in there too. So that's all we need to do for our to-do table component at the moment. We do need to put some markup into the template though to actually display something. So as I say, we're just going to use a table, and we're going to have a heading, and we're going to have a row in there. And we're going to have a few headings. So we'll have the to-do or the task, when it was created, when it was due, if it's complete or not. So that was that little checkbox that we had before, the little toggle. And we'll also have a remove button as well. So those are the headings for the table. Let's create the body. And the first thing we're going to do is, if the array of to-dos is empty, we'll just display a message to the user. So we're going to use ngIf and say if the to-dos, that input that's on the component, is equal to 0, then we'll have a column which is spanning 4 columns, and we'll just say nothing to do today. So that's the case if we don't have any to-dos, but we want to loop through all of the to-do items if we do have something in the array, and then just display some information. So that might look a little bit something like this. We'll have a tr, and then we're going to use ng4 and say let to-do of to-dos. And I'm going to use an ng class directive here just to specify a different class for this row if it's actually been done. So we'll apply a class of done if the to-do.done property, which if you remember is the boolean, is actually true. If not, we won't apply that class. So the rest of the columns here, so for the first one, we're just going to use template interpolation and grab the task text, which is on the to-do item. And then we'll grab the created at timestamp, just pass it into the date pipe to display when it was actually created. And then the other date that we want to have is the date due. So this is the one that we specify when we actually create the to-do from the front end. And then with the other thing we've got here is an input of type checkbox, which will basically be the button to say it's done or not. And then the other thing, we'll have a span here with a trash can icon inside it, and that'll be to actually call the delete function. So that's roughly what our table is going to look at. We can now get this set up into our app component and actually see how this looks. And we'll create an Angular service to fetch the data from the API and actually populate this table as well. So we'll head on over to the app component, and actually let's get this serving now. So npm run and start should get the Angular app up and running. And go back to, we had the tab open here from the start. So this is just a default Angular page. Let's get rid of all this. We've just got an empty page at the moment. And I'm going to start off by just wrapping everything in a div with a class of container. And we'll just put a heading level 1 tag of to-dos. And then the next thing is we're going to make use of the app to-do table, and we'll pass in to the input of to-dos on that table, we'll pass in a variable, which you're going to define on this app component of all to-dos. In fact, let's set that up now, because otherwise it will complain in the browser. So, oops, all to-dos is I-to-do array, and we'll just set that to an empty array to start off with. And now that table is set up and ready to go. And I guess while we're here, let's just set up the form that we're going to be using to actually create new to-dos as well, just so we can get an idea of how the page is going to look. So input, placeholder, enter a task, and we'll give it a name of new to-do task, and type is text. And we'll have another input as well, and this is going to be the new to-do due date, so we'll use this as a date input field, and Save that. And then we're just going to create a button. And there we go, we've got our form set up ready for us to create a new to-do when we're ready. But let's actually start working on connecting our front-end app to the API. So we're going to create a service which will basically call the couple of endpoints that we've created. So let's just set that up first. So with Angular, we can generate a new service. We'll call that to-dos service. Set the app running again. So now in our to-do service, we can make use of the HTTP module that Angular provides us to actually make those network requests. So to do that, we basically go to the constructor here to inject the HTTP service. So HTTP client. And rather annoyingly, when you do this with Angular, you actually need to make sure that you've got in the app module or whatever module you're using this in, you need to make sure that you've got the HTTP module installed as well. So in the app component, we want to make sure that we've got the HTTP client module, and also we'll import the to-do table component as well, so in case we reuse this at some point. Now let's tell this app component as well about the to-do service that we just created. And now once we've done that, we're in a position where we can start using that to-do service. I'm noticing some errors here in the console. I think you can't find the date pipe in the to-do table component, and that's probably because in the to-do table component we need to make sure that we're importing the common module as well. Yeah, there we go, got rid of that error. And you can see that that's appearing now as well. We've got nothing to do today, so we can see that that app to-do table component is actually working. We just need to pass it in some to-dos to actually render something. So let's go to the to-do service. We're all set up to make some network requests. So let's create the base URL that we're going to be sending requests to. So that's just localhost 3000, which is the Express app, obviously. Make sure we're assigning that a value. And then we're going to create a function on this service called getToDos. We don't need any parameters for this. We're literally just going to be sending a request to the first endpoint that we created. So let's use the Angular HTTP library to do that. So we're going to say this.http, and then we're going to make a GET request. And something that's interesting about these functions that Angular provides you is they are actually generic, so you can provide them with types as well. So what type of data is this request going to give us? Well, it's going to give us an object back with a status property, which is a string. And it's also going to give us a data property, if you remember from the response that we get here, the data, and that will be each of the to-dos that's been found and sent back. So it's going to be data of I to-do array. So that's really handy because we're using that interface that we created all the way at the start of the tutorial, and we're making sure that the data fits that schema all the way through our app. So the request we're going to send to, it needs to go to a specific endpoint. So we're going to go to this base URL, and then we're going to /todos. And so that should be enough to get this data back from the endpoint into this object, but we're not really that interested in the status because we're assuming it's going to work at this point. So we'll pipe that and just map the response that comes back to remove the status, and we're just interested in the data. And now what this getToDos function will return for us is actually an observable of I to do, which will be an array. So now we have in our service the function to actually go and fetch all of the to-dos from the database, from the API. So let's, in our app component, that's the top level of the app, so that's where we want to actually make the call to get the data. So what we're going to do is say that the app component implements ng-on-init, and then this ng-on-init function is called when the component is created. So this we need to actually inject the to-do service as well. So in this constructor, so private to-dos service, to-do service. So that's the service we were just working on where we set the get request up a moment ago. So this to-do service, we're going to get the to-dos, and then we're going to subscribe to that observable. And on a next, when something else comes down the stream, when the request is completed, we're going to get the to-dos back from that, and then we just need to say this dot all to-dos is equal to the to-dos. We'll also log them out as well so you can see them in the console. And now what we should find, let me just make this a little bit smaller, is that when the app loads, in the app component, this ng on init block is running, and we're calling the function to get all of the to-dos and also logging them out to the console here too. So there you go, you can see that is the array of data that's retrieved from the API from our get route. So that is the first step in getting our front-end app connected to our back-end API service. As you can see, there's a few steps involved, but now we're set up, our app is pretty much ready to accept more requests and be configured to work with the data in the API. So just before we go back to the API to actually implement some more routes, let's actually put the post route or the post command into the front-end app so that we can actually put stuff into the database too. So the first step really, I guess, is to create the to-dos service function to do that. Yeah, and this one's pretty straightforward really. So in the service, we're going to create a route called a function called create new to do, and it's going to create accept a new to do object as the argument, and we'll shape that. It's not a full interface of the to do because we only really want to have the task and the date due, and we're going to set the boolean to be false for done in the API, so we only want a couple of bits of information from the front end here. So this kind of mirrors what's in the form. We've got the task and the date, and that's pretty much all we want to have. So we've got task and date due. Date due will be a string here. And all we're going to do is this.http post and this.base URL / to-dos. And then the second argument in the post request for Angular is a new it is the payload, so it's going to be the new to-do object, and we need to return that observable from here. So notice we haven't bothered typing this post request with the generic because we're not really interested in the data that comes back. If there was an error, we should probably catch that and see what happens, but all we're doing really is posting the task and the date due into the database. So what we can do now is go over to the app component and create the function that will be called when the form has been filled out, because don't forget the form here that we can see is actually in the app component. So we'll create a function in here called create new to do, and we'll create the payload that we want to send to the service, to the function. So it's just going to be task of this.new to do task, and date due is this.new to do date. So these two properties here we're going to set up as members of the app component, and that should be strings, and we can use these in the model that we're going to bind to these two form controls here. So let's just initialize them as empty strings to start off with. Let's go back down to the create new to do function here, and all we're going to do with the to do service is just call the create new to do function that we created a moment ago, pass in the to do payload, which is just task and date due, those two properties, and then we're going to pipe that into a stream with the observable, because what we want to do is when we've actually created a new to do in the API, we want to refresh the to dos that are on the page, and we could do that by manually inserting this item into the to do array that's in the app component, but it's probably worth just like doing a fresh network request and pulling in all of the latest to dos from the database. So that'll look a little bit like this. We'll use the merge map rxjs operator. Again, we're not worried about the result that comes back from the post request to create the new to do, but what we're going to do is just call this dot to do service dot get to dos again, and then we'll have a side effect using the tap operator, and this is the refreshed to dos that we've got, and then we'll say this dot all to dos is equal to the refreshed to dos that have come back, and then we just need to subscribe to this stream and when we get new values coming back, we're not too worried about these values because it's already been set as a fresh to do. We'll just log the result. So there's two more steps now to actually get this form to work. The first is we need to bind the two properties that we've got up here to the actual form controls in the app component. And we also need to set up the event for when this is actually changed and clicked. We actually need to update those properties and call this create new to do function. So let's grab the new to do task to start off with. So in the app component template, so for the input, we're going to use the banana in a box of ng model. Oops. Too many double quotes. So that's going to be new to do task, so the name of the task that we want to create. And then we do that again for the, let's make sure we get the right spelling and name for it. New to do date. Pop that into there. And then as mentioned, when we submit the form, we want to call the function. So it's create new to do. That's the function that we want to call. And we're getting an error at the moment, basically because this app component doesn't know about the forms module. So in our imports, we'll just import forms module up here as well from Angular. There you go. And we've got the form back up and running. Let's just close this down. And theoretically now we should find that if we do put in a task and a date and click the create button, just say do something else, and let's give it a date. If we click create, nothing seems to happen, which must mean we have an error here. So yeah, there is an error response. Can't actually see any errors in here, so let's have a look at what's happening on the server. So that has crashed because there's a non-null constraint, which basically means that we didn't provide the done property from the front end. So we need to go into the server to make sure that we're setting that done property when we're creating a new to do. So over here in the app.ts for our server, let's change that. So we're getting the request body here, which really isn't a to do, it's only really the task and the date due. In fact, if we change that here, that'll help us with our typings. So task is string and date due is a string as well, or a date. So we can create a new object here, new to do, and it's basically going to be the two properties that have been provided by data, but we're also going to set done as false as well. And that new to do is going to get saved into the repository, into the database, instead of just those two properties. So hopefully that should sort us out. Database is up and running again, so the API should be okay. In fact, if we just clear this down, should find if we click create now. Yeah, there we go. So that's looking a bit better. We've got a new to-do that's been added into the database. You can see that coming up here in the query logging. And we've got two to-dos now in the array in the app because we've added another one into the database. Okay, so whilst we're here in the app, we might as well actually go ahead and create the other two routes that we want to use within our app. And we're going to have a patch endpoint, a patch request to actually change the status of one of the to-dos. So we're going to toggle the done status in the to-do model. And then the other one is just a delete request, which will basically remove that item from the database. So let's go into our app.ts and sort out those two routes. So the patch request for changing the status is a little bit involved because we need to do a few different things. We need to find the to-do in the database and then update it and then save it back into the database. So let's get the endpoint route set up. So same signatures as before. And we want to take in from the front end app the status that we're trying to set. So is the to-do done? And we'll take that from the body. So request body property of done. And then the other thing we want to do is get the path parameter here for the ID of the to-do, which will just be a number. So the ID is equal to parseInt rec params.id. And then once we've got that information, we can make a request to the database to actually work out whether we can find this to do or not. So found to do is equal to await to do repository. Remember we set that up early before. Find one by, and then you pass in the kind of arguments that you want to search by. And because we know the ID of the to do, which has been passed in from the front end, we can just find the to do by the ID, which is the easiest thing to do. So with this found to do, what we can do is set its done property equal to is to do done. And you can see we're getting some TypeScript errors here because possibly we might not find that to do in the database. So the linter here is warning us, telling us that found to do could possibly be null. So we could just wrap this in an if statement. So we could say if found to do, then we want to make sure that the to do properties of done is set to whatever's been passed in from the front end. And if that's the case, then what we could do is just then save this. So await the to-do repository.save and found to-do. Again, that's going to complain because it could possibly be null as well. So we probably want to just do that in here. And let's just set up results here so that we can then make use of that in our response from this route. So we're going to return res.json status, okay, and then we'll set back the result, which could possibly be undefined if we can't find the to-do, but our examples, it should be fine. So there you go, we've got the two-stage process there of finding the to-do in the database, updating the model that's returned, and then saving it back to the database as well. So if we send a patch request now to this any ID that matches a to-do in the database and pass in a body property of done, we can configure whether or not it's complete. So that is the patch request. We want to have a look now at the delete request as well, if we want to actually delete something. And this is pretty straightforward. Again, we're just going to delete on the to-dos to-do of a particular ID. And let's grab this signature here again, save us some time. And what we're going to do is get the ID as we did before. So the ID is parsing from the request.params.id, and then the result is going to be await the to-do repository .delete, and it works pretty much the same way as the find functions as well. You just pass in some kind of arguments that you want to search by. In this case, it's going to be the ID, and we're going to save that and then return the result in a JSON object again. So status is OK, and the data is the result. So that's the delete endpoint, which is just finding a to-do in the database, removing it, and then just returning any result that we get back. So that is our APIs pretty much set up. The routes are all in place. We just need to connect the few buttons that we've got in the app to those additional endpoints to toggle the status of the completed items in our database, and also to remove things as well. So let's head back on over to the Angular app. And the first thing I'm going to do in the to-do service is just create the functions that will actually make those network requests. So the first one's pretty straightforward. Update a to-do done state. We can pass in a whole to-do for this. And the reason for that is because we want to get two bits of information. We want to get the ID of the to-do, and we also want to get the done state as well. So this is something that we're going to be updating in the actual model within the tables that we've got. So once we've got that bit of information, we can say this.http patch, which was the type of the route that we set up, and the base URL, and it's going to be to-dos, and then the ID is the path parameter, which we've already destructured here from the to-do. And then we want to set the done property in the payload as well. So we'll pass that in as the second argument. So that's the function to update a to-do, to make the network request to do that. The other one's even easier. So to-do, and we want to delete a to-do. And we'll pass in the whole to-do object to this as well. Okay, and the reason again for that is just so we can destructure the ID. We could just pass in the ID as a string as well, and that's fine too. So const ID. So we're going to return HTTP, and this time it's a delete verb that we want to use. This.base URL, to-dos, and then the ID. And that's all we need to do. We don't need to pass in a payload to that delete function. Just the ID, and it should find it in the database and delete it. So all of these actions need to really be triggered from the to-do table, because that's where we're actually showing the to-dos to everyone. So when we click one of these buttons, we want to actually fire an event. But because the management of the overall to-dos is done in the app component, what we're going to do is just say when one of these buttons is clicked, we're going to fire an event from the table up into the app component, and that will have the responsibility of dealing with the actual network request. So let's go to the to-do table, into the template, and we're going to first of all wire up some functions to the events for these two inputs. Well, I guess the trash can isn't really an input, it's just an icon, but there you go. So when we change the value that's in the checkbox, we're going to fire an event, and we'll say it's toggle to-do done state, and we're going to pass in the to-do that we're currently looking at in this array. And yeah, that should be it. Oh, and the other thing we probably want to do with the checkbox as well is set its checked property equal to the to-do done state. So if it's Boolean true, then checked will be true, and it will automatically appear as true when the app loads, when this table is rendered. The other thing is for the trash can, when we click that, we want to call a function called remove to do. To do, and we're going to pass in the to do to that. So you can kind of maybe see how these functions are kind of like marrying up to the functions that are in the service that we just created. But we're going to obviously send these as outputs from this function. So to do. So the first one that we've got here is the toggle to do done state, and then remove to do as well was for the delete. Well, for the trash can. To do. And okay, we've got rid of the errors now in the browser. And what we're going to do in these two functions, when they're called, we're actually going to call some outputs on this component. So let's actually set up those outputs to start off with. So we've got an output here of changed. So this will be when the complete toggle checkbox is clicked. So we'll create a new event emitter from Angular, and we're going to pass a to-do out of this. And the other one's exactly the same, but this is when the trash can's being clicked. So for the toggle, when we receive the to-do in this function, we're going to check its done function and just say its done function is the inverse of whatever it is. So if it's true, it'll change to false. If it's false, it'll change to true. And then we'll say this.changed.emit the to-do. And then this is pretty much the same in the remove to-do, but we're not worried about the state. But we're going to say this.deleted.emit to-do. So now we're just going to be firing these outputs from this table when any of these are clicked, and we just need to catch those in the app component and fire off the network functions. So if we head over to the template for the app component, this is where the table is being used, and we've got two outputs that we're going to catch. The deleted, so we're going to delete a to-do with the event. And then the other thing is changed. I guess you could have more things being caught on this changed event if you wanted to change like the text or something like that for the to-do as well. To-do done state and the event as well. Going to get errors because we haven't set those up, so let's create those in the app component. So after the create to-do, So and the other function we needed to create was delete to do, which has the same sort of signature. We get an event, which will basically be a to do. And then in each of these functions, it's just a case of calling the relevant function in the to-dos service. So in the set to-do done state, this to-do service, we're going to call the update done state with the event, because we've already in the table actually modified the done state in there. So we're just literally updating the to-do in this instance. So when we get that back, we'll just log the console result. The UI should already automatically update for us with this one, so we don't really need to do anything else. Let's just check here in our network tab. We should see this going through. If we actually click the complete button, you should see there's an update there, and we've got that appearing in our query logging in the API as well. And if we refresh the page, you can see that that complete state is actually persisted to the database. Let's just swap that over. So yeah, that's been sent to the database, and when we reload the app, we're getting the fresh to-dos with the done state updated. So that's all looking good. The set to do done state is done. The other thing is the delete, which is a little bit more involved. We're going to do what we did before when we create a new to-do. We're just going to refresh the to-dos list in the app once we've actually deleted the item from the database. So we're going to pass back the event to the delete to do function, and this is what we did before when we created a new to do. We're going to merge map and just make a call to this to do service .get to dos, and just make sure we're getting the refreshed to dos from that second call. And then this all to dos is equal to the refresh to do data that's come back. And then again, we just pretty much can subscribe and log the result to the console. So let's go over to the app, just make sure we've got the latest version. If we click one of the trash icons, you can see it's been removed from the list, and refreshing the app to get the new to-dos, you can see that that has actually been deleted from the database and is no longer being returned from that GET request. So that is pretty much the app complete. You can see we've got all of the routes set up for managing all of the resources in the app, and then the front-end app is making use of those endpoints to actually manage the data. Just before we wrap up, let's have a look at styling this. And I'm just going to copy and paste some styles into here because it didn't look the best. Because it's not really the point of this tutorial to make it look pretty, but just so it's a bit more readable. So there you go, there's the to-dos table component itself. Let's apply some styles too as well, just to order things a little bit nicer. And there you go, you can see that we've got a nice interface for our to-do app. And there you go, you can see we can add new items in here. So do something else, put in a date, click create, and that's added into the database, and then we can see it in the app as well. So there is a complete app for you created using TypeORM, and hopefully you can see that it makes life a lot easier when dealing with data and working with your database connections. And of course, if we wanted to swap out that SQLite database for something a bit more robust, we can actually just change the type of database that we're using, maybe when we deploy it to our production environment. Of course, one thing that's missing from this app is any kind of validation. We're just accepting any type of data from the user. And so if you want to start adding validation into your backend web servers and apps, then you should check out this next tutorial where we go through a full app again, but this time we're focusing more on how to validate data that's been passed in from the user. Thanks very much for watching, and I'll see you next time.